Hello friends, my name is Ben and welcome to another Alchemy learning video. If you're new here, this channel is dedicated towards producing educational videos centered around human health. In this video, we're going to go over the basics of the ECG, or Electrocardiogram, a common clinical test that records the electrical activity of the heart. First, we're going to review electrical recording basics. Electrodes measure the differences in electrical charge between two different points. So here we have a series of cells with electrodes at either end, the one on the right being the recording electrode. At rest, when all of the cells are negative, there is no difference in the charge, and thus a flat line is recorded. However, as the cells begin depolarizing, we can pause in the middle of that wave, and here we see that the charge is imbalanced, with the positive towards the recording electrode. So remember, the electrodes are recording the external environment and not the inside of the cells. As all of the cells become depolarized, there is once again no difference in charge between the electrodes, and the trace returns to a flat line. Once the cells begin repolarizing, there is once again an imbalance of charge, this time with the negative charge registering at the recording electrode, leading to a dip on the trace. We must also review the nerves that run through the heart muscle to understand the flow of the ECG. So at the top of the right atrium, there is a group of cells known as the sinoatrial node, and these are the pacemaker cells of the heart, and they initiate the depolarization and subsequent contraction of the cardiomyocytes. The wave of the depolarization spreads down through the atrium to a second group known as the atrioventricular node. Now, after a short pause here, it progresses through and down the septum, down the bundle of His, before spreading back up the ventricles of the heart along the Purkinje fibers. With those basics, let's now examine the classical ECG trace that you're probably familiar with, and this comes from a 3-lead setup. In this, one lead is placed under the right clavicle, another under the left clavicle, and the last on the base of the chest on the left-hand side. In this case, the left clavicle forms the ground electrode, and so the charge is read downward across the body, and this runs across the heart. We'll now examine the complete cardiac cycle. First, the pacemaker cells in the sinoatrial node depolarizes, and this spreads through the atria, leading to the P wave on the trace as those myocardiocytes depolarize. As the wave now spreads down the bundle of His, there is a large upward deflection on the trace. And note that this deflection is much larger than the P wave because the ventricles are a much larger mass of muscle, meaning that the myocytes are depolarizing, which leads to a greater change in potential. Following this, there is a large downward deflection which results from the depolarization spreading up the Purkinje fibers. Remember that the recording from the electrodes is relative, and now that the charge is spreading away from the electrodes, this records it as a negative change. Once the wave of depolarization has finished, the cells need to repolarize, and this is seen in the T wave. Now, given that the previous depolarizations were positive deflections, we might expect that the T wave, being a repolarization, would be negative. However, because this negative wave is also spreading away from the electrode, beginning at the base of the heart and moving up, this makes it appear as a positive deflection. Note that the atria also repolarize. However, this deflection is lost within the much larger depolarization of the ventricles during the QRS complex. What this video hopefully demonstrates is that not only is charge important, but also the direction of travel. And this means that recording from different electrodes will give a different result. For example, if we measure downwards from the left clavicle to the left chest, this is the trace that we see. The QRS complex and T wave are still visible, but the P wave is noticeably reduced as it is further from the plane of recording. If we measure across the body, From the right to the left clavicle, this is the trace that we see. The P wave is again visible, but it is reduced, as is the QRS complex. And that is again because we are not recording along the plane in which the electrical current travels. Now in future videos, we'll discuss more complex ECG setups that make use of many more leads, and these allow us to paint a more detailed picture of the electrical activity of the heart. In summary, this video has described the basics of the ECG, the spread of the electrical activity through the heart, and how this correlates to the trace we see on the ECG. Thank you for listening, and once again, if you found this video useful, please consider liking, subscribing, and sharing to help spread the word. And if you found this video particularly helpful, then I would be so grateful if you could head over to Patreon to further support the work. You can also find me on Facebook. Thanks again, friends, and see you next time.